This security brief focuses on answering the question, what's the big deal with network firewall? To start, let's look at a typical firewall deployment for a multi-location network. For this example, the network has 3 offices as represented by these 3 squares. This node down here is our headquarters location, and we'll call this location 3 and location 2. Now all of these offices are interconnected through an MPLS network, which is represented by this cloud here. Each is connected to the MPLS network via a local loop represented by each one of these lines. And we have our basic network. Now traditional network design places an aggregate internet connection at this headquarters location right here. And I'll say I represents internet. And this aggregation point here acts as the internet access for all of the offices on the company's network, including the headquarters. Now, we all know every internet connection out there needs a firewall, and since this internet connection's at the headquarters, so is the firewall. We're going to draw that as a green rectangle right here. There's our firewall. And management of this device is done by security admins that work in the office right here at HQ, and changes are executed locally. In order for someone at Site 3 here to access the internet, they travel across the MPLS network, across their local loop, down the headquarters location's aggregate local loop, out the aggregate internet connection, through the firewall, and to the internet. The same thing goes for Site 2 here. Travel across the MPLS network, down to the headquarters location, and out through that firewall and to the internet. Obviously, anyone at headquarters here does the exact same thing. Now, there are variances of this design. Say we place an internet connection at each location, then a firewall at each location. But the problem with that design is it doesn't scale in any reasonable economic way. Imagine adding a few new locations or changing firewall rules in a design if you had like 500 locations. It'd take forever, which is why most folks stick to this tried and true setup. This setup does have some glaringly obvious shortcomings though. For instance, if this local loop gets cut in the parking lot, as represented by that big red X, by accident, or if the firewall decides to quit working and become a brick, none of the branch offices have access to the internet. Furthermore, most local loop connections terminate to a demarcation through the same conduit, meaning that if one of these local loops is cut, then likely both of them are cut. What I'm saying is that this design introduces a single point of failure for the entire enterprise's internet access. In today's world of zero risk for downtime, that certainly doesn't work. Now, these glaringly obvious shortcomings are no secret, and lots of engineers design around them. Let's take an example of a solution to this problem. So we have our 3-location network connected with MPLS, and we'll place that main internet aggregation at the HQ again, just like you see here, and the firewall sitting there just like in our last design. But this time we'll add a second backup internet connection coming from Site 3. And we'll call this I. And as we all know, if you have an internet connection, you need a firewall in front of that internet connection. Keep in mind, we also need to design some kind of failover mechanism between these 2 firewalls in case of a primary connection failure. So here, everyone goes through this main firewall to the internet. Sites 2 and 3, same deal, just like they did before. And if this internet connection fails for whatever reason, let's say that that local loop is cut, then the failover mechanism that's in place, likely BGP, signals the system to know to fail to this secondary location and head out here to the internet, and so on and so forth. Pretty straightforward design, and this is the most common solution for the problem that arises in our very first simple design with single point of failure. The problem here is that we spend a ton of coin to do it. Local loops are expensive and take a long time to install. So I had to spend lots of money on the primary internet connection and enough bandwidth to serve all my locations. Plus I had to replicate that cost here at Site 3. Then I had to be sure that enough bandwidth was available on both of these MPLS connections to handle the traffic from all my other sites aggregating here. And on top of this expense, I had to purchase another firewall and likely pay additional fees to enable support and ancillary features on both. What I'm saying is that while this alternative certainly works in most instances, it ain't cheap. It really isn't even reasonable. But get this. What if my headquarters location and my number 3 branch office are located in and around Miami? Now, I'm certainly no expert, but what happens if a big storm hits and takes out both the HQ and Site 3? Maybe it cuts the connections, maybe the power goes out and generators can only operate for a few hours. Use your imagination. In that case, my redundant design fails again. Now I know you can't plan for everything, I get that, but what if I were to tell you that there's a much better way of doing things? What if we were to take this network design and flip it on its head? What I mean is, what if we rewrote the rules of internet aggregation and took our core services to the cloud? Here's how it works. Let's take our 3-site network that we played with before. Remember, we had Site 3, Site 2, and HQ. Go ahead and label these. And all of these locations are connected together by MPLS. And each location is connected to the MPLS network with what we call a local loop or a connection. But this time, we aren't going to put any internet aggregation links at HQ or at Site 3. Instead, we're going to take advantage of the nature of MPLS and get creative. See, Paytech has something called Network Firewall. What it does is it places huge multi-tenant firewalls out there on the MPLS edge. So this is our multi-tenant firewall on the MPLS edge at the peering and transit points. What that means is one end of this firewall is connected to the MPLS network. The other end of this firewall is connected to the big wide internet. By doing that, Paytech can essentially make the network firewall a node on the MPLS network, and all internet traffic flows to it in the cloud directly to the big wide internet without relying on a single site to aggregate the internet traffic. I know what you're saying. Wait a second. That's not true. Well, I haven't exactly shown you the whole design. See, since MPLS is a meshed topology by nature, Paytech can place lots of these huge multi-tenant firewalls all over the country and connect them redundantly to provide a primary and a backup. And that's exactly what they do. So here we'll add another firewall, again directly connected to an internet upstream somewhere else in the country. And each customer is assigned to a primary firewall and to a secondary firewall. They're geographically dispersed and they're redundant. So when users at any of my branch offices or the headquarters need to access the internet, they simply traverse the MPLS network, just like this, and head out by way of this primary firewall to the internet. Same goes for Site 2 and Site 3. Now what's really cool is, notice that there is no aggregation at a single site. So, if my headquarters location has a local loop that's cut in the parking lot, Sites 2 and 3 still maintain access to the internet, completely agnostic of the state of the headquarters location's connection. We couldn't do that in our situation before. Worst case scenario, a natural disaster hits and both 3 and headquarters are cut off, like in the example we used before. 2 still has access to the internet, and so on and so forth, and that scales to infinity. If this firewall or its connection fails, or God forbid a natural disaster occurs, the failover mechanism recognizes this huge outage and automatically fails the entire network's firewall protection and internet connectivity to this secondary device here. So now when headquarters wants to head out to the internet, since primary isn't available, it goes to secondary, and same with Site 2 and same with Site 3. And remember, these 2 firewalls are geographically dispersed. So if a natural disaster occurs and takes out the primary firewall, The secondary firewall is far enough away that it wouldn't be affected by that natural disaster, but close enough within the region that latency would not be recognized between the access time for the two firewalls. Now, if that's not cool enough, here's the best part. This company doesn't have to purchase firewalls or licensing or maintenance contracts, and they don't have to buy local loops with huge bandwidth because they aren't aggregating a bunch of internet access all over the place. Even better, customers are connected to the internet with virtual connections, meaning bandwidth adjustments are a simple tweak in the system, and Paytech can provide anywhere from 1 meg symmetrical access to 500 meg symmetrical access at the push of a button. No more waiting 90 days for local loop upgrade if the business expands. On top of all that, this company can choose to manage the firewall through a web portal themselves or have Paytech do all the management for them. Changes don't cost anything extra, just a simple call into the Security Operations Center or a ticket through Paytech online portal. Who knew that the cloud could actually bring more scalable, better security to the enterprise? Paytech did, and they're doing it every day with Network Firewall. Until next time, I'm Rob Anderson, and this has been a Security Brief.